Good afternoon, everybody. Welcome to Nature Live Online. I'm Alison. I'm your host for today's talk. Now, if you're new to Nature Live Online, we're an event that usually happens at the Natural History Museum in London, where we give our visitors a chance to meet and speak with some of the scientists that work behind the scenes at the museum. And you can find out a bit more about the brilliant research that they're doing. Now, our doors for the now have to be closed, but that work continues. So we decided to bring our science and our scientists direct to you at home. Now, today I'm going to be talking Mars with one of our researchers, Joel. Now, I've got lots and lots of questions for Joel. It's a fascinating topic, this one. But as always with Nature Live, we would love to hear from you, our audience, as well. So do post any questions you have in our comment section. I know we get many more than we can often handle, but we'll do our absolute best to get through as many of your questions as we can in the time that we have. But let's meet our speaker today. We'll say hello to Joel.
Hi, Alison. Hi, everyone.
Hi, Joel. How are you doing?
Yeah, good, thanks. How are you?
Yeah, very well. I'm very excited for this talk. I love a talk about space. Let's first of all start by finding out what you do at the museum, what your research is about.
Sure. So I'm based in the Earth Science Department at the Natural History Museum, and I'm a postdoctoral researcher where I work on using images from spacecraft around Mars to investigate the ancient geology and climate of the red planet.
Wow. And how did you get into this area of work? Were you always interested in space?
Yeah, so I was always interested in kind of space and geography and geology, and I probably watched too much Jurassic Park and space and sci-fi movies as a kid, and this seems to have just been the natural place to end up in.
You can never watch too many sci-fi movies. When you were younger, did you ever imagine you'd be studying the geology of Mars?
I think when I was younger, I wanted to be a paleontologist. So it's not too far off, but no, I didn't think I would end up doing this. No.
No, I think it's probably fair to say of all the planets in our solar system, Mars is the one that has captured the public imagination the most. There've been so many films and books, so many outlandish theories of the red planet. What is it about Mars that you think is so interesting?
I think that the fact that we can see it with our eyes if we look up in the sky at night is probably one of the reasons that Mars has kind of been captured in the public consciousness for so long. In terms of film and literature and all these other mediums that the Mars appear in, I think that has kind of slowly set the ball rolling, and as we've had more and more space exploration, it's kind of captured Mars kept Mars in the public consciousness quite prominently.
It really has. And why is it so interesting to scientists?
Yeah, so we, as a scientist, one of the reasons I find Mars really interesting is because we can see pretty good evidence on its surface that Mars was and still is in some aspects quite Earth-like, but it's very different. The temperature on the surface of Mars today is very, very different to the Earth. It's very cold, it's very dry, and we're interested in the reasons for some of those differences. How did a planet that may have started out being quite Earth-like end up being this really cold, very, very dry desert? And also the implications for life. Could life have ever existed on Mars if we do see all these similarities between Mars and the Earth?
Absolutely, and long ago we did have an idea that there might be life on Mars, but ideas they've changed an awful lot over the years, in good part due to the changes in technology that we're able to use to study Mars. We've got an image, I think, of Mars through a telescope here. Tell us about this image.
This is a really cool image taken by an amateur astronomer, I believe, just from a back garden telescope. And even though we're looking at Mars from the surface of the Earth, we can already start to see some really interesting things about its surface. We can see color changes across the surface, which may tell us that there are different rock types which make up the surface of Mars. One of the most prominent things about this image is that at the southern cap there of Mars, as we can see an ice cap. an ice cap that we know is made of water ice, which tells us, that there are some even today, some quite first order similarities between Mars and the Earth.
Absolutely, and just for fun, and because it's a really cool image, we've actually got the equivalent of image of Earth. So this is like a Martian's eye view of Earth.
Yeah, this is a really cool image of the Earth and the Moon. This is an image taken from a camera that's actually in orbit of Mars, so not quite from the surface of Mars, but it's from a camera on board a spacecraft called the HiRISE camera. It's a NASA camera, and this is just a really incredible image, of what Earth and the Moon look like from the orbit of Mars. And we can see some, we can start to, if we were Martians in orbit of Mars trying to learn about Earth, we could start to see some, we'd start to learn some, a few things about the Earth just from looking at this image. We can see water, we can see clouds, we can see land. We can see that the Moon is very, very different. So we might start to wonder why these, what these different things are on the Earth and the Moon, and why these differences might have arisen.
Absolutely, and we can already see, that Mars is that the Earth, is a much bluer planet than Mars.
Yeah.
Now, we don't have to rely on grainy telescope images anymore, do we? We've actually sent satellites to Mars. I think we look at some of the satellite images. So this is from Mariner, is it?
Yeah. So these are kind of some of the first really clear images that we got back from spacecraft that we sent to Mars. This is from the Mariner 9 spacecraft in the 60s or 70s. And we can just from these quite low resolution images, 1 kilometer a pixel or so, or 100 meters a pixel or so, we can start to see some really interesting topographical features. On the left there we have the Valles Marineris canyons, which are these huge canyon systems around the equator of Mars. They're about 4,000 kilometers long, 10 kilometers deep, and some of the biggest canyon in the solar system. And it starts to make us wonder what could have formed this canyon. And on the bottom right there, we have the Olympus Mons volcano, which is the largest volcano in the solar system. It's about 20 kilometers high or so, and it's about the size of France. So if you were, to be on top of that volcano, which is 3 Everests high, you'd effectively have no idea how high you were, because it would just take up the entire horizon. So even from these fairly low resolution images, we can start to learn a lot about the surface of Mars.
And we can see that it's more interesting. Its geology, its geography is a lot more interesting than we might have thought. And we've actually landed on Mars as well. I think we've got a couple of images of landers. So this is an early one.
Yeah, so this is from one of the Viking landers, which landed on Mars nearly 50 years ago. And we can see on the surface there's broken up rocks, and we start to wonder what processes might have broken up these rocks. We can also see sand ripples in between the rocks, which are blown by the wind and transported by the wind. So we're already seeing some good similarities on the surface too between the Earth and Mars.
And our final image, I think, is a beautiful one. It's that classic red planet, that beautiful red dust. This is from Pathfinder, isn't it? Rover.
Yeah. So this is from the Pathfinder and Sojourner rover, which landed on Mars in the 90s. And yeah, like you said, we can see this the kind of characteristic red orange Martian dust, which covers the surface and gives the planet its hue. And this was the first rover mission sent to Mars. The rover you can see there isn't actually very big. It's only about 30 centimeters long or so. So it isn't a giant rock, but it is quite deceptive that there is no scale bar. And the fact that rovers really started to transform our understanding of Mars, because we didn't just have to land at one place. We could land and then start to move to different places and start to ask really interesting science questions and have the ability to answer them.
Absolutely. We've got some questions coming in from our viewers. We had a very lovely question from, let me see if I can find it. It was asking if people have ever landed on Mars, have ever lived on the subject of missions.
Yeah, so not yet. People have never landed on Mars. The only place people have actually landed on in the solar system is, other than the Earth, is the Moon. But there are some tentative plans to send humans to Mars in perhaps as early as the 2030s.
And a lovely question from Violet on YouTube, who's age 8, asking, are there clouds on Mars and are they a different color? What have all these missions told us about Mars itself? Do we know about its climate, its weather?
Yeah, so there are clouds on Mars, and we can see them in orbital images. A lot of the times we don't actually see you don't necessarily get these the images with clouds advertised, because we tend to look at what's on as a geologist. I'm interested in what's on the surface of Mars, so clouds kind of block the view. But yeah, I would imagine that if you were to look up at clouds on Mars, they would appear as a slightly different color, because the atmosphere has different properties. In terms of climate, Mars is very, very cold. It's very, very dry. Think Antarctica, but probably 100 times worse.
Mm. Not a very hospitable planet, particularly for us humans.
Not for humans, but a great environment for rovers.
Now, we've actually mapped the entire surface of Mars. Is that right? I think we've got an image. Yep, that's Mars.
Right. Yeah. So this is a global image mosaic of Mars taken by the Viking spacecraft. So this set of images is nearly 50 years old. But even so, you can still see quite an incredible amount of detail in these images. We've now actually imaged Mars. Obviously subsequent missions have gone to Mars since Viking, and we've got global coverage of the surface of Mars at about 5 meters a pixel. So that's about the equivalent scale imagery to what you'd see in Google Earth. And this image, this map of Mars is actually a topographic map of Mars. So this isn't what you'd see with your eye. This is the colors here are showing elevation. So the whites, browns, and reds are the really high areas of Mars, going into the yellows, greens, and blues, which are the really low areas of Mars. And you can start to see some of these dynamic topographic features that I was talking about earlier, these huge volcanoes, these deep canyons, these huge impact basins. And the fact that much of Mars is covered by lots and lots of impact craters tells us that much of the surface of Mars is very, very old. So a lot of these processes that probably modified Mars quite early, that modified the surface of Mars, probably happened quite early on in its history. We're talking 3 to 4 billion years ago, so a very, very long time.
This is an amazing image. You start to wonder what exactly is it that's caused all of these fascinating features.
Yeah, so we one obvious thing that has modified the surface of Mars is impact craters, volcanoes, the wind. We know the wind has modified the surface of Mars quite a lot. But the one that that tends to get a major focus is obviously water. Liquid water is essential for life, we think. And we see pretty good evidence in the geology and the geography of the surface of Mars that the surface has been reasonably well modified by liquid water at some point in the past. So these images you're looking at now are features that we refer to as valley networks. You can kind of think of this as what you would see in your if you were to go into kind of a mountainous or hilly region on Earth, you would see rivers kind of eroding the landscape and transporting water. And this is what you tend to see. We see these features on Mars as well. And these valley networks we think are quite similar to rivers on Earth, that you're kind of looking at the upstream portion of the river where erosion is taking place and water's being transported downslope. And it's really hard to explain these features without water. But kind of a key question that we're interested in as scientists, that we're really trying to answer, is how long these erosional rivers took to form. And that has kind of major implications for how long life would have had to develop if it ever existed.
Absolutely. We've got, I think, an artist's impression of what one of these crater lakes might have looked like on Mars. It looks like a very, very habitable, eminently habitable environment. Very friendly to life.
Right. So these rivers, if we look at how they relate to impact craters are essentially a big hole in the surface of Mars. And what what we can see in many examples is that these erosional, ancient dried up rivers tend to flow into impact craters. And where that happened, we think that water potentially pooled and formed a lake, which, like you saw in the image previously, looks like quite a nice, quiet, quiescent environment. Perhaps somewhere that life could have developed if it had long enough.
So we have lakes on Mars.
Mhm.
You mentioned potential rivers as well. Do we see signs of flowing rivers?
Right. So we were talking about rivers and lakes, and if you remember the valley networks that we showed a couple of slides ago, we think those are the sort of rivers that would form in an upslope region, kind of your mountainous or hilly terrain on Earth. Now, if you imagine going, walking down a river and the changes that you'd see as we go out of our mountainous region and the land tends to get flatter. We enter our kind of floodplains. The more the way the river behaves would start to change. What we're seeing in this image, this is an image of the surface of Mars, the main image there, and we can see these ridge-like features. And these ridge-like features are really interesting. They've been a major focus for my research for quite some time now. And we think these ridge-like features are essentially ancient river deposits. So it's quite unusual thinking about a river in this way because it's preserved as a ridge in the landscape, whereas a river is negative topography. It's not positive. And how we think these features form are the river transports sediment, the material that it's carrying, and lays it down on the riverbed. Now, after the river dries up, that material is more resistant to erosion than the material surrounding the river on either side. So our floodplains, the dried up floodplains get eroded, and the river sediment, the river channel sediment, is left as a ridge within the landscape. And it takes a bit of time to get your head around these features because they are quite unusual, these ridges. But we do see some nice examples on Earth as well, where of ancient rivers that now form ridges. And the example that was on the bottom right of the screen there is from Utah in the southwestern US, where these ridges are continuous for several kilometers. And this is a really nice image taken from a helicopter that from a plane, sorry, that you only really appreciate the scale of these features from the air.
They're incredible. I would have instantly recognized that as a river. It's fascinating to find that out. Do we see evidence of flowing? And rivers on Earth, they meander, don't they? They change
Right.
their flow. Do we see that on Mars as well? That kind of dynamic?
Yeah, so if we look at more examples of these kind of enigmatic ridge features that we think are rivers, we can see pretty good examples of what we think are meanders. So on the top right image there, you can see some features that look a little bit like meanders. So if you think on kind of we're in our downstream part of the river where we have our floodplains, rivers tend to meander, and this is essentially what we think we can see in that top right image. On the bottom right image there, we have just some examples of how meanders can change the course of a river over time. This is a nice colorized map showing the patterns of the meanders. I think this is from the Mississippi River in the US. But we do see similar features on Mars, which it tells us that the rivers probably lasted for a significant enough amount of time to form these meanders. They weren't a rapid catastrophic event. They weren't a one-off thing. They were around for some time, but we don't quite know how much time that was.
It's a tantalizing prospect for life, but we'll back to that question. Now, one of the ways that we recognize these features is by comparing them to what we see on Earth, don't we? And if we have a look at some features on Earth, they are remarkably similar to what we're seeing on Mars. I was astounded when I looked at these images. So do we see most of these features on Mars?
Right. So yeah, we can see examples of features like meanders there. So that I was just speaking about. We can see possibly some evidence for dried up waterfalls, features like lakes, features like deltas that form at the end of a river. as the river enters a body of water. Glaciers, yeah, we can see some pretty good evidence for glaciers as well. So yeah, by using the Earth as an analog, by comparing the features that we see on Mars to the Earth, we can really start to learn a lot about what Mars was like billions of years ago. But by learning about these features on another planet, we can also start to learn a bit about a bit about how these things form on the Earth as well.
We've got a lovely picture of what we think might be an ancient riverbed on Mars, and comparison to Earth, and we can see the little pebbles that have perhaps been eroded by water.
Sure. So most of these images before that we were looking at were from orbit. This is actually from the image on the left there is from the MSL rover Curiosity. And this was kind of like the first time that I think the scientific community kind of came together and said, okay, there were probably rivers on Mars. If you think about what you'd see at the edge of a river on Earth, you would expect to see rounded pebbles that have been rounded by water erosion. And this is essentially what we can see on these riverbeds on Mars when we look at them with rovers. And this is just to compare on the Earth. You can see some strong similarities in the way the pebbles have been rounded, and transport by water is really the only way to do that.
And what about things like river deltas and even oceans? Do we see signs of those on Mars?
Yeah.
Bigger features?
Yeah. So kind of scaling up. We've not been to many of these places with rovers to investigate, because there's only so many places we can land. But yeah, we can see some pretty good evidence for things like deltas, potentially even oceans scaling up. And I think we're going to talk about that in a second.
Absolutely. We've got a question from YouTube on the subject of oceans, asking what work has been done to look at the Great Northern Martian Ocean. How certain are we about that hypothesis? Was there an ocean on Mars?
That's a really good question. So if we follow the pattern of all these ancient rivers and lakes, what they tend to do is they tend to kind of, if they ever flowed, they would have flowed into this huge basin, this huge low-lying area in the northern hemisphere of Mars. And one of the major questions that we have is, and you can see it there really nicely in the image, the blue areas that we think this ocean could potentially have been. We're not very certain on the hypothesis about whether there could have been a Martian ocean. The community, the people who investigate Mars tend to be very split on this idea. There's some pretty good evidence. We know water was flowing in, but what we don't know is whether there was enough water to fill this ocean fill this basin rather, that occupies maybe a third of the planet's area. But there are a couple of upcoming rover missions. So the NASA 2020 Perseverance rover, which launches next month, and the ExoMars European Space Agency rover, which launches in a couple of years, are going to land very near this potential ocean basin. And hopefully we'll be able to answer, or at least start to answer with rovers, what we haven't been able to answer from orbiters. So it's going to be an exciting couple of years in terms of Mars exploration.
It's a really exciting time. Who knows what we're going to discover? Just while we're on the subject of rovers, Jess, age 12, has asked how the rovers are powered when they go to Mars.
That's, a really good question. So most rover missions before have been powered by solar energy. So like some houses on Earth have solar panels, rovers also have solar panels as well, which gives them their energy. The example that you're seeing on the screen there, the Curiosity rover, was the first rover not to be powered by solar panels. It's actually got a little nuclear generator on it, so it's powered by radioisotopes, which so nuclear energy, which means that it is less reliant on the sun, so it doesn't need to have fantastic weather, but it you can think of it a bit more like a battery. It does have more of a limited lifespan, but hopefully it has lots of years of exploration still to go.
And we've had another really interesting question from William, aged 9, who was asking if there could still be water under the surface of Mars, because most of the features we looked at so far, they're really ancient, aren't they? Are there signs of more recent water?
That is a really good question. So we actually have sent missions to investigate this question before. So from orbit, we thought that we could detect water beneath the surface of Mars, and NASA sent a lander to these regions, and like a little good geologist, it had a shovel and started digging, and actually found water ice only a few centimeters beneath the surface. So yeah, there's pretty good evidence that water ice is quite widespread beneath the surface of Mars. We think that we'd have to go quite a lot deeper into the surface to find liquid water, though.
Do we see glaciers on Mars at all?
Oh, that's a good question. Yes, we do see glaciers, and I think we have a really nice image of a glacier. So most of the features that we were talking about, the rivers, the lakes, they were very, very ancient features that were 3 to 4 billion years old. These features that we think are glaciers are actually a lot more modern. They're only perhaps thousands to tens of thousands of years old. So geologically speaking, that's quite recently. In terms of our lifespans, that's a long time ago. And these we think this feature is a glacier. You should be able to see it's kind of flowing down slope, like glaciers do on Earth. One question that we're really interested in is whether the glaciers are actually moving today. And the answer is, I think they're probably not. We think that they're actually frozen to the surface of Mars and that they're completely still. But if they were moving in the geologically recent past, glaciers have to flow to form. They have to flow down slope. It doesn't seem implausible that in today's conditions, or perhaps even in the not too distant future, glaciers could actually move again.
Oh, that would be fascinating. We've got a great question from Elijah, aged 9.
Mm-hmm.
He's asking, where did all the water on Mars go? That is a brilliant question. If it was once wet, why isn't it anymore?
That is a really good question. So yeah, we think that there was quite a lot of liquid water early on in Mars's history. So Mars's atmosphere today is quite thin. So that means the surface of the planet is quite cold. It's very, very dry. But we think billions of years ago, the atmosphere was a little bit thicker, which meant that it had a greenhouse effect. So the atmosphere would have heated up the surface and meant that water could have existed as liquid. In terms of what happened to that atmosphere, we don't know. We think at some point the atmosphere was being removed by the solar wind, so what comes out of the sun, making the atmosphere gradually thinner and thinner, and that we eventually hit a point where liquid water was no longer stable. In terms of what happened to that water, we think the water could have gone underground and been frozen as ice, or it could have been lost to space. It could have become vapor and then broken down and then disappeared into space. But that's, again, it's an ongoing question, and one that we're not entirely sure of. But those are kind of the two where the water could have gone places.
And linked to that question, Joseph, aged 8, was asking if we think Mars was sort of similar to Earth many, many years ago, could the same thing happen to Earth that has happened to Mars?
Oh, that's a good question. So the short answer is no. So we think the reason, just to give a bit of reassurance, we think the reason Mars lost its atmosphere so early on was probably because it never had a magnetic field. So magnetic fields essentially protect our atmosphere from the solar wind and stop the atmosphere being removed. Earth has a magnetic field, which protects our atmosphere. You can tell this by, if you have a compasses point north due to the magnetic field. And yeah, so that was probably the reason Mars and Earth had such divergent paths, where they were a bit similar in the past, but now they're quite different.
Yeah, we think we're fairly safe on Earth. Now, of course, lots of our viewers are asking about life on Mars. We've got Emma, we've got Lily asking about the potential for finding life on Mars. Could there have been life in the past? Could there even be life nowadays?
Right. So in terms of today, we know the surface is probably quite inhospitable, so not very friendly to life. The atmosphere is very thin. There's a lot of radiation hitting the surface of Mars, which is not very good for life. It would essentially sterilize the planet. If there were to be life today on Mars, more friendly environments might be beneath the surface. So investigating, the subsurface of Mars is quite challenging. We'd obviously have to land and drill down into the crust. We think the surface, life might have existed at or near the surface billions of years ago. The answer is we don't know whether it did or not, but we can certainly see environments, places like rivers, lakes, possibly even oceans that potentially would have been friendly for life to develop in, because we know there was relatively abundant water in the past. When we think of what that life might have looked like, life probably didn't have a very long time to develop in these periods when it was habitable, when it was friendly to life. So we think the life probably was very simple, probably microbial, not complex life, and probably nothing like what we see on Earth today, at least. We'd probably have to look back into the fossil record on Earth to see what life could have been like billions of years ago to potentially have things to compare to.
It's a pity, no Martian dinosaurs or Martian octopuses, but possibly Martian microbes, maybe fossilized.
Possibly microbes.
And the best place to look for those be where we find these features of past water?
Yeah, so kind of the way we investigate these places, we tend to kind of follow the water is the mantra. It tends to be the logic. So the two new rover missions that I mentioned earlier, the Perseverance rover and the ExoMars rover, are actually going to places that we think were ancient lakes in the past, and they're going to look for evidence of ancient life. So that's going to be really exciting.
Incredibly exciting. Speaking of the missions, we've had a question from Ollie, age 7. He'd like to know if you can tell us how long it would take to travel Mars. How long do these missions? How long does it take to?
Oh, that is a good question. So we tend to launch missions to Mars when the Earth and Mars are closest together in their orbits around the Sun. So it generally takes around 6 to 9 months or so for a mission to go between the two planets.
So that's quite a long time.
Not as long as many people think, but yeah, still a reasonably long time. If we were ever to send humans to Mars, that would be probably an insufferable amount of time to be in an enclosed environment.
Definitely. We've got lots of questions coming in from our viewers, some great questions. So I'll just go through a few of them. So we've got Jason on YouTube and Jack on YouTube. Jason asking if there's water on Mars, does that mean there's oxygen on Mars? And Jack asking what the Martian atmosphere is actually made up of.
Right. So we know there must be, there must have been some oxygen on Mars because, water, H2O, has an oxygen molecule in it. And a lot of that is probably locked away as ice at the moment in the polar caps and in the subsurface. In terms of what the atmosphere is made of, the atmosphere is mostly made of carbon dioxide, so CO2. And we think that in the past, the CO2 atmosphere was a lot thicker, and that probably, that created this enhanced greenhouse effect, which made the climate potentially warmer.
And Shreya, age 9, was asking about the gravity on Mars. There is gravity, but is it it's not as strong on Mars as it is on Earth. Is that right?
Yeah. So Mars is a lot smaller than the Earth, so the gravity is a lot weaker. I think it is about a third of the Earth's gravity. But yeah, it not as low as the moon, but quite a lot lower than Earth.
And a great question from William, age 9, asking if Mars has storms.
Oh, that's a really cool question. Mars does actually have storms, but they're very different to the storms on the Earth. Mars has dust storms. So the red-orange dust that covers the surface of Mars gets kind of whipped up into a frenzy, and sometimes you even get a global storm of dust which blocks out the sun. And if you remember earlier, I was talking about how a lot of rovers tend to be solar powered. When we have dust storms, that is a big issue for rovers because they block off the sun, and that was what sadly ended the Opportunity rover mission a couple of years ago when during a global dust storm.
And we have the dust storms. We've got quite a few people asking whether it rains on Mars or whether it ever rained on Mars. Do we know if there might have been a water cycle at one point?
Right, so it definitely doesn't rain on Mars today. So Mars is very, very dry. We don't think we can see liquid water to anywhere. But the fact that we have rivers, lakes, and seas, tells us that it may have rained on Mars. What we don't yet know is whether Mars was covered by snow and ice. So the snow we could have had snowfall on Mars that later melted, or we could have had rainfall on Mars. And we don't quite know whether there was rain or whether there was snow that melted.
Interesting. There's so much more work that we need to do. We think we know a lot about Mars, but there's many questions, aren't there?
Yeah, the more we look, the more questions we tend to have. So it's a really fascinating area to work in.
And Nadia on YouTube was asking, and this is an interesting one, if we brought life to Mars, if we brought microbes, if we brought plants, for example, like the Martian, could they perhaps evolve and adapt to the Martian environment?
That's a really good question. I don't think I can fully answer it, but we know that life has existed on Earth for 4 billion years and has adapted to a huge range of dynamic and very difficult environments to live in. So it stands to reason that perhaps things could adapt to the very harsh conditions on Mars today.
It's an incredibly harsh environment for us. We had a question earlier for YouTube asking, Ash was asking whether we could live on Mars potentially. Is that something that might happen eventually?
Potentially. So we've not sent any humans to Mars just yet. There are some tentative plans to send humans to Mars in the early 2030s. It would be very, very difficult to live on Mars. And I think this kind of tends to be a thing that's often overlooked. I think the best comparison to potentially living on Mars is look at what it's like in Antarctica when people try and live in the Antarctic bases and the very, very harsh conditions that they have to live there in, and then multiply that by 100, and that's probably what it would be like to live on Mars. But there are humanity is capable of very ingenious things, and there is a lot of water ice in the subsurface of Mars that could potentially be utilized. So there are the resources there that could help us adapt, but it would be a very, very challenging endeavor to live on Mars.
It really would. We've got quite a few people asking, I think on Facebook, how long the Martian day and night are.
That's a good question. So the entire Martian day is actually very similar to Earth. So Mars rotates around its axis in about 24 hours and 35 minutes, I believe. So only a little bit longer than an Earth day.
And quite a few people asking why it's so hard to get to Mars. We've sent quite a few missions, haven't we? And not all successful.
Yeah, so we've sent about 50 missions to Mars over the last 50 years, and there's only about a 50% success rate. And the main challenge of getting to Mars is landing on Mars. If you think about landing on the moon, it's not easy, but it's simpler to land on the moon because the moon has no atmosphere. whereas on Mars is a very thin atmosphere. So the atmosphere on Mars is kind of enough to cause a lot of friction when the spacecraft is descending, but it's also not enough to it's also not really enough to slow the spacecraft significantly down. So it's kind of dealing with these two end member problems and getting the balance quite right that makes it very difficult to land on Mars.
But we are getting better, aren't we?
Oh yeah, we're definitely getting better, and you know, as time has gone on, missions, the success rate of missions has definitely got a lot higher. And you know, currently there are 5 spacecraft orbiting Mars, representing 3 different space agencies, and a lander on a rover on the planet. So you know, we've landed on Mars successfully 8 times now, I think. So yeah, you know, it's definitely getting better.
It's a really exciting time for Martian research. I can't wait to see what we come up with in the next few years. Just very briefly before we wrap up, we have a really great question from Hannah for you, Joel, asking if you could, would you go to Mars?
I think that would depend on whether I would have the opportunity to come back. I mean, I think so. I would love to go and explore Mars. If it was a one-way trip, I'd maybe have to think about it a bit longer. But yeah, I mean, the idea of exploring the Martian surface in person is a really exciting prospect. But probably only if I had the chance to come back. Maybe a 2 to 3 month stay would be a good amount of time to, you know, look at some rocks.
Plenty of time to explore, see what you can find. Just one last question from Sarah on YouTube. It's quite an interesting. She'd read that the Mars's soil is toxic. Could anything be used to grow crops for on Mars at all?
Well, that's a really interesting question. So I don't think I can quite answer
Tricky one.
whether the Martian soil is toxic. What I will say is that Mars doesn't really have soil. Soil, when you think about soil on Earth, most of what makes up soil is actually the remains of life. Whereas Mars, the soil is really what we call regolith, so it's just broken up bits of rock. So we probably couldn't grow plants into it without modifying it first. I think we've all seen The Martian and know how Matt Damon grew his potatoes. But yeah, it would be a difficult challenge that we'd have to figure out a way of addressing.
Yeah, I think for the time being, we'll be exploring Mars from a distance. Well, Joel, thank you so much for talking to us today. It's been absolutely brilliant finding out about your research, seeing all those amazing images, and learning about what we're finding out about water on Mars.
Thank you. It's been really good.
And hopefully we can speak to you again soon. But we'll say goodbye to you for now.
Bye.
And thank you to you, our viewers, for all of your fantastic questions. I do apologize if we didn't get to all of your questions. We do get so many that come through, but they were all fantastic. Do join us again. We are back on Friday. We've got a brilliant talk about termites lined up for you. And of course, we're here every week. So every Tuesday at 12 and every Friday at 10:30 a.m. Keep an eye on our social media channels for updates about upcoming talks. And remember, you can go to our YouTube channel and you can watch some of our previous talks as well. Thank you again for watching. We hope to see you again soon, but I'll say goodbye for now. Take care and see you soon.